talk at the end of the day. We're already away out the door. There we go. I'll keep this quite tight. What I'd like to do is offer you something maybe slightly differently. Lights is whatever we want to do it, Jim. I'm fine with that.
Do you want some more light?
If you want, audience, if you're okay, you're okay. If you're okay, that's fine. My background, the energy sector, oil and gas sector. What I'd like to give you is a life cycle approach to testing, the whole life cycle in itself. And the key thing for me was, or is, all about knowledge sharing. Individually and collectively, what is it we can do to make a difference? The big thing in my industry, in my area that I've been working, particularly in fire for many, many years, oil and gas, was Piper Alpha. That was the incident, if you like, that made such a tremendous change in the industry. And it's went global. And a lot of the key insights and methodologies and tools that we've been using in the oil and gas sector has been working great, actually, working really on a global basis. So why is, I know the writing's a wee bit small. The reason for bringing it in, there's a couple of things. I'd like to bring in two kind of key principles. ALARP Principle, which we're probably all well aware of, coming in there. And something called safety critical elements, safety critical equipment is where that's coming from. The big difference there, 167 fatalities there, but the big difference happened in legislation. We went from prescriptive legislation to goal-setting risk management legislation. We put a value in life. And that has been pretty difficult for people to say, can I actually put a value in life? We had one of the chaplains, and he said, how can you put money or value into life? But we do. We do a case for that as well. And there's something there, as we'll see, Grenfell's happening, and it's unfolding as we're going and going. The Cullen inquiry went on here for many, many months, similar as we'll see. And one of the things that there's a guy there, the name of Brian Appleton, who was one of the advisors to this group. And he came away with a saying after it, and he said, the sum total in quality of our individual actions will determine whether the men and women offshore here will live or die. I'd like to put to you the same thing. The men, women, children in our communities, really what we do together. So what I would like to do is some kind of knowledge sharing, some stepping stones. And from that, there was a piece of legislation came, and it's been around for a while, okay? Prevention of fire and explosion emergency response. It goes a whole life cycle. The design. What are the standards we're actually building it for? What's its purpose? Is it for drilling? Is it for production? Is it a floating vessel? What is it? What's the standards? It's difficult for you to read there, but basically it goes from leadership right through. It includes emergency response, escape routes, all these areas. It talks about something called verification, internal, external verification, a life cycle approach to this. And we talk about risk management coming in. The bits we see there, hazard identification, the old hierarchy of control, elimination, substitution, etc. All the various things we've got there. It brings this idea of risk. What is it? What are we designing it for? What's its standard? It's suitability, availability. Will it stand up? So we've got this big fire. I don't know if you've seen some of these, if you've passed Grangemouth or somewhere like that, and you've seen a sort of tripping vent, this big gas flame coming through. You take that and take it vertical, it can fill this room. It's big. Overpressurization, bang, it's there. It gets us. That's part of the thing that we need to be aware of. That brings in this one here, which we're all familiar with, this ALARP. It's low as reasonably practicable. We put fancy numbers on this. 1 in 1,000 years, 1 in 10,000 years. We bring it into an acceptable level. The key thing for me here is all the components we're making over the whole give us a certain risk reduction factor. How much risk does it bring it down? So from an ops perspective, is there a probability that something can fail under load or demand? What is it? What do we need to do to make sure that the design meets the criteria for the purpose, for the use in itself? You're familiar with the reform order that went through a couple of years ago. The branch was party to the legislative sounding board for that as well. We get two words put in: reasonably practicable. From the 1974 Health and Safety at Work Act, there's a whole list of case law on what that actually means. So we'll find as time goes on, we look at fire, particularly in buildings, the built environment. What I mentioned was this thing here about the barriers that we have in place. So what's the hazards, the purpose, the various things that can happen? In our industry, it tends to be kind of high pressure hydrocarbons. It can be oil, gas, jet, fires, etc. Vapor cloud explosions, all these various aspects we're looking for there. The barriers to it, that starts from the design right through to inspection, operations. And another interesting thing within this here is, and we've touched on it earlier, competence of staff. Are they good enough? Do they know what they're doing? And when you're doing your inspection and maintenance, I'll touch just a little on human and organisational factors as well. This is part of, within the legislation, for over 20 years it's been in place. And since 2013, human and organisational factors are an integral part of what's classed as the offshore safety case. I appreciate it's high hazard industries, but human factors, potential for human error. Human error happens, is it a slip, a lapse, or mistake? The unintentional errors, intentional errors, taking shortcuts at times. What's the pressure on the organisation to do things a little bit quicker of that? Normal, abnormal, emergency conditions. So when we're doing our barriers of protection from there, we also we do something called a human HAZOP. What's the possibility of something going wrong? We ask ourselves the question, what if, so what next? What if it goes wrong? What's the recovery mechanism? And if that fails, what's the emergency response coming from this side? So I say that's been in for many, many years coming within that. We have the life cycle approach. Our analysis coming from here, which is basically saying, what's the purpose, what's its use? Is it a hospital? What is it? Is it an office block we've got here? Design it to that standard. What are the international standards, the local standards? I've been working from a place called Hammerfest up in the Arctic Circle, away down to Middle East, Singapore. A lot of the international companies, if there's insufficient standards within the countries they're working, international oil and gas company have their own standards, their engineering codes and standards. Identify these safety critical elements, and I'll show you what they are in a moment or two within there. The performance standards for them. Availability, reliability, functionality, survivability. Bang, we hit it. Is it going to work? Will it fail? Under load. Maintenance, availability, reliability. What does it look like within the organisation? If you're squeezed a bit from time to time, we'll maybe let that inspection or test just be an overdue. And you eventually get to the stage that your multiple risk reduction factors cumulatively are actually failed out with this safe operating zone, safe operating area within it. So that's the kind of framework for that. The type of things we've got here, crane operations, temporary refuge. There's something there. It's what we're talking about here, having a box, if you like, to protect us. This guy, Brian Appleton, when he was doing this investigation, they're interviewing people, and he asked this guy, he said, what was it? He said, shouted out something. What was it? He said, is there anyone from Santa Fe here? Well, why did you shout that? He said, I didn't want to die. I didn't want to die alone. So they went into temporary refuge. They were in it for a long while in Piper. And eventually smoke was coming through and coming through. They were told, they'll say, stay inside this safe zone. But no one was coming to get them. All the systems had actually failed. It did protect them for a considerable amount of time. But really what we're saying, all this stuff here, is not academic. It's about people, about real people living or dying and having systems and setting standards. Standards are not academic, particularly here. Safety critical elements, that's the systems, within it all the equipment. And it's a life cycle approach to them within it. Integrity of the safety critical elements, the big E and the wee E is the equipment, all the little bit of components that make up the whole will determine whether through this availability, functionality, reliability will actually work or not. On the demand, and what's some of the things we look for? Structural integrity, supporting structure, top sides, navigation, nav aids, rotating the equipment, we see here. Flare and vent systems, gas processing, process, the corrosion, the integrity, the quality of the activity sets that we're doing within it here, fire and explosion, looking over there, ignition, someone was mentioning earlier there, making sure that it's back to the old triangle of fire. And mentioned a bit about cabling, similarly as well, the standards that we do for that, the demand coming from it, ventilation systems, passive fire protection systems. Have all these systems, then we bring a person in. The person starts taking components or bits off. How well do they put them back on? Is the integrity compromised in any way? Cranes, lifting, so it's all equipment and things, they all have the potential for fire, escaping, evacuation. The amount of people there, their capability of reacting under load. The performance standards, planning, we're saying there, performance standards, a life cycle approach we got to there, through the life cycle of the installation. So that's through the design stage, the appraise, select, define, execute and operate, putting things into place, making sure that it'll work okay with it. What is the standard? How high or how low is it? Do we make sure we've got it within this safe operating envelope, within this ALARP area? So we have regulations on that, and we're tested and verified against that. With, here's the barrier protection system that we see here. Structural integrity, is it going to fail? We've seen that with some of the passive fire protection, the fire stopping that we've been talking about. Containment. Is this idea if you get any pressurized systems, can we keep it tight? Can we keep it within? Ignition control, we mentioned that earlier. EXD, flame-proof equipment. EXI, intrinsically safe kit. And we're saying that with something called SIL, safety integrity levels. On demand, what is the probability that that component will actually operate okay, or will it fail on demand? Shutdown systems, emergency response. Shutdown systems could be isolation valves. On demand, will it actually close within the specified time? Will it leak? If there's any external flame within that, will it stop it from operating? Will it structurally remain solid within there? I remember, a second or two, I was working in BP 40's field at one time, and we had quite a high leakage rate in one of the major valves. The operator, BP, who I worked for, done a bit of testing. We went to fire service school down in Montrose. We looked at the leakage rate of this particular valve. That would cause a fire of X size, and we had to demonstrate the fire teams could go in and knock this fire down within a matter of minutes. And that was a risk assessment to allow the continued operations. Didn't want to shut down at that time. So it's linking into the operational firefighting as well as the passive side. You'll see some of the colours there. What does this mean? It means really on a day-to-day, week-by-week, month-by-month basis, these systems are monitored by staff. And we know cumulatively how well are these systems working. Then the question comes for the management team. The ALARP principle, if we're going up or above that line, getting close to it, the operator has a call to make. Do they continue operation or do they close down? There was one of the managers, I used to run process safety integrity management workshops. They not normally manned installations. The manager there said to me, I came to that place. They said we have a large shipping lane coming down here. And we had quite a number of the systems were actually starting to fail. We couldn't get on for the testing. And then there was something which was slightly uncomfortable. And you may have witnessed or seen this in your own businesses. The manager was sick. So at every level within the management chain, someone was stepping up to the next level. So the organisational capability was a bit kind of compromised as well. So it's looking, I say, at everything within that, the whole life cycle approach, which we have with that. Unfortunately, you'll not be able to, I can read a wee bit with this one. What I'll do is I'll put it on our Scottish LinkedIn website. I'll put this presentation on there. Let's see, I've got a wee bit here. This one is fire and smoke detection, heat, flame, manual alarm call points, local satellites, system components. This is just giving you an example of what a performance standard is. Detectors appropriate for the operating environment. Design, has the design been done properly. She was cited to rapidly detect correct inputs to fire and gas, so that's how your cabling come in there. Design reviews, detection systems, manual alarm call, buttons, review the maintenance, and then you've got the frequency in months, sides. The other one we have here, we also do testing against reliability, availability, survivability, and integrity. That's all part of the complete system. Been in place for over 20 years, folks. So there's things that we can maybe learn from that within it as well. Really saying is, on a regular basis, we'll check it, make sure it meets the performance standards to bring risk down to an acceptable level. That's really what that's saying to us. And we can have all the systems of the day, of the world. What we find from time to time, it's people like you and me. And it may be whoever you're working for, your senior managers, your CEOs. They're setting, to a certain extent, the tone, the culture of where we're all working within. Investigating incidents over a period of many years, the industry, goal-setting industry, working with the area I'm working, the health and safety executive, have come up with these 10 areas. These are the areas we need to be looking at in respect to prevention of fire and explosion and emergency response. All these areas coming from looking at the potential for error coming in there. So if I've got the kit in, if I've got my sprinkler systems, my detection systems in there, I'll get guys who are coming along, they'll put their wee tests up here, we'll check it. Have they got the competence to do that correctly? So when we start looking at the competence profile for staff, since 2013, it also includes an element of human and organisational factors as well. We're getting the right thing, the right standard looking for within there. Staffing, do we have suitable and sufficient people to do the activity sets that we're doing within there? Communications. It's back to this whole idea. Your cut per cost principle, common understood shared picture. Do we all mean the same thing? Does it mean the same thing to us? The design aspects from it here. What is it? What probability that I got here is inside this. is this container suitable and sufficient to actually do this job in itself? If I turn it upside down there, what's going to happen to it? It's looking, what is the capability for the staff that's working in this area? The design bit, I work globally. So what I would maybe say in English language may not necessarily be the same in Arabic or Urdu or anything else. So we need to make sure that we've got the right equipment for looking for here, the culture coming in here, maintenance error. I say the possibility of something going wrong within that. And the difference that made a difference after Piper was this thing here, of this idea of sharing. Step change in safety. What is it we can do? So industry in itself have decided, okay, from time to time there's confidential things, but by and large everything is shared with the name under the umbrella of safety within here. So sharing and learning. And what I encourage, I think, our industry, and that's where we're heading to just now, is the principle of doing this, of the collaboration aspects within it. That's really what it's about. And that's what we encourage ourselves to do. There is a model that's been there over 20 years, a lot of lessons and insights that potentially could be shared. So hopefully you found it of some interest. I've rattled through it to keep the energy going, because we're nearly time to go home. Nearly, eh? Have you any questions for me as we finish? Kirsten, are you going to do your presentation as well?
Well, I did put together just a small presentation looking at the fire resistance test, but if everybody wants to go home, I don't blame you.
Any questions, folks? Anything? Or are we just time to go?